Hi, my name is Afia Owusu-Forfie, and I'm the founding president of Coders Who Travel Incorporated. I also lead the bootcamps as a facilitator who brings together experts in my rich network in the mathematical sciences disciplines. Today I'm going to share an amazing lecture by one of our experts called Theophilus Siame. His lecture, he is a data scientist at AT&T and a PhD candidate. And he will be sharing how you organize your Python code, and together I will be asking him questions. Some of the cohort members will also be asking him questions, and so
hold on.
Enjoy.
Just a minute. All right.
Unlike other boot camps,
you can continue, Theo.
Tutorials that you can find on the internet.
Can you see my screen?
Without Q&A.
Yes, we see PyCharm.
We have representing veterans or former military
PyCharm is one of the
who joined
IDEs,
the session with
you
their
can
questions
use
and
to
answer. The first one is
create
Ashley.
your Python applications. So that is what I'm going to use throughout. But at some point, I'm going to demo some few stuff also in VS Code, so that we can at least balance the two.
You can follow up with me.
If you look at if you just go to Google and type PyCharm, this page should come, and you can just click on your download and follow the prompt.
The Coders Who Travel
so I think that is for the PyCharm, and I think everybody else is familiar with the
Facebook
VS Code already, so I'm not going to talk about it.
Twitter, Coders Who Travel, and our email info@coderswhotravel.com.
So today we are going to be talking about classes. So classes is just an important part of Python programming or any other programming you can think about. It is usually called object-oriented programming, which tends to be one of the major obstacles for beginners when they are first starting to learn Python. So there are so many tutorials and lessons covering object-oriented programming, which is free online. You can Google search and you'll find most of this object-oriented stuff. But going forward, I'm going to be talking about I'm going to talk about 4 concepts, and one of them is inheritance, abstraction, polymorphism, and encapsulation. So let me see if I can check this. Okay, I'm going to be asking you a few questions once we go along. So you'll be confirming some stuff whenever I'm sharing my screen.
Was that from Afia?
Sorry about that.
Afia was the first instructor, so.
Yeah. Because you just mentioned her name, so I got confused.
No, that's.
So you can see my screen, right?
Yes.
Okay. So this is a machine learning website. Mostly people use this scikit-learn for machine learning, and we are just going to learn something a little bit here before we move to the main OOP, which is object-oriented programming. So if you look at, let's say, the third one, which is you see something like from sklearn dot ensemble, and then you see another keyword import, And then you see another class called random forest classifier. So basically this thing, you can just copy them and paste in your VS Code and run it and stuff like that. But somebody will ask, how did they write this? How did they come about this whole thing? How do you even read it? So the way you read it is like you are looking at a folder. So let's say the sklearn is a folder, and let's take it that the ensemble is a file, okay, a .py file, and then import. And this import meaning that there is a class called random forest inside this file, ensemble. So this is how you read it. So yeah, so basically that is it. So you are looking inside a folder called sklearn, and within this folder there's another file called ensemble, and within that file there's a class called random forest. So I hope everybody got it.
Except what is a class?
Yeah, so we'll be defining what a class is.
Okay.
So these two green stuff from and import, they are all Python keywords. They are special to Python. So you can use it for any other thing. So let's move. So a class, so a class is basically like, let me see if I can open this. Yeah, so if you see my screen, a class is just like a blueprint. And that blueprint, you can create instances of those blueprints, which you call objects. So if you have like a car class, you can create instances of those car class, and those instances are called objects. So basically that is a class. So you create a blueprint, and within that blueprint, you have so many attributes and methods. And once you have those attributes and methods inside that class, you can go elsewhere and keep calling that class over and over, or those methods or those attributes, whatever you want to do with those attributes or methods, you can keep calling them in different forms. And the different forms are like the objects. And then the objects, you use the objects to access whatever you have in your class. So you can use the object to access the attributes as well as the methods. So that is a class. So you create the class using the class keyword. We'll look at all this stuff, but I'm just explaining for now. So you can use the class keyword to create a class. And then the class is just a blueprint that defines the nature of the future objects that we are looking at. And from these classes, you can construct instances. And those instances can be a specific object created from a particular class. So these are too technical. So we'll just look at, once we start looking at the examples, then we'll get to understand what is going on. Okay, so I'm going to create a folder or a directory, which I'm going to call demo 1. And inside that demo, I'm going to create another, going to create a package. And that package, I'm going to call it, see, example example. Okay, so this is the directory, and this is a package. And with PyCharm, once you create a package, it automatically creates a file called __init__dot.py. If you open it, it's empty. Now inside that package, I'm going to create another file, Python file, which we are going to call coders, like coders who travel. So I'm just going to call that that file coders. And within that coders.py, I'm going to start to create a class. And that class starts with a keyword class. So that is a class. And you can see it in this color. And then I'm going to call, the name of this class is going to be coders who travel. So basically that is the name of our class. So mostly you start the class name with caps. Okay, you don't do this. The convention is you don't do the camel case with classes, so you start with the caps like this. Assuming it was just one word, you can just start with coders like this instead of doing something like this. So you can see there's a wiggly sign symbol under the coder, so it tells you that you have to do something to it. So once you make it caps, it accepts that. So that is the convention. So if you look at a lot of codes or classes, you see that it starts with caps instead of lowercase. And then the pass, meaning that I'm not ready to declare my attributes and methods yet. So I'm just letting it pass for now. And once we do this, we can call this class. Okay, so if we say coders equals coders, because it's a class, you need to end the class with a parenthesis. You close it with parenthesis. And then I can now call coders, this one. Okay, let me call it C so that it doesn't confuse people. So I'm calling it C. And then the C is just the object of the coders class. Okay, let me put it back. Coders who travel. Sorry. Coders who travel. So that is our class. And then this letter here is the object. Okay, so let me start. Coders who travel class. And then instance of coders who travel. And the C is the object. Objects. Okay. So once you do this, you can, let's print something out. So C, which is the object. So once we print, let me do this before. Yeah, so you see this green thing here. So it helps me to run the code in the IDE. So I can just click on this green arrow here, and it's going to print out the object C. So if I hit on that green button, you can see that it gives you some information about the location of this object in memory. And we are not interested in that. So we can, because we don't also have any attributes or methods in this class, if we do dot, you're just going to see default objects, because any object that you create, it comes with the defaults created by Python. We didn't create all these things, so it came with Python.
Your quick question.
And okay.
The if name line, why did it come? Is that linked to the play button?
Yeah, it's linked to the play button.
Okay.
So once you type with the ID, once you start typing main, you see it pops up here. Okay. And then once I hit enter, it fills the space for me with that entire code. And it's linked to the play button. So as before, we just want to print the C. Once I click on it, then it prints out this information for us. Okay, so that is the basic class we can think about. So now we can create another class, and this class we're going to call it, let's say, a dog. It's a dog.py inside our package. So once we create a dog, we want to start with a keyword class, and then we call it a dog. And now this is where the fun starts. So if you think about a dog has certain attributes and methods. We all know a dog has a breed, it has a color, it has some weight, it has so many things about it. It has a nose, it has so many attributes about this dog. So, and the dog also performs certain functions. You can use the dog for, the dog can bark, it can run, it can serve as security at the airport, whatever. You can use dog can do so many things. So all you need to do is to look out for the attributes of that dog, as well as the functions, what the dog can do. So that is what you put inside your class, your attributes of that dog, as well as the functions of that dog. So let's create. So before we start, we need to initialize the attributes of the dog. So let me comment out this. Create attributes of the dog. And then the other one is to, let's say, create functions of the dog. So before we start, we say def, any method that you want to create inside Python, we start with the def keyword. And it comes with a special method created in Python, which is underscore underscore. Once I start typing underscore underscore, you see the init popping up, which is predefined. You can see it here, predefined. And it comes also with a self argument. And this self argument, I'm going to explain it as we go along. I don't want to confuse anybody for now, but this self could be anything. Actually,
quick question, Theo. You mentioned init, but you've chosen int. Is that?
Oh, okay. I think it's a typo. Sorry.
Okay.
Yeah, it's a typo. Yeah, with a self, it can be anything. But it's a convention that all Python programmers must follow, because others are also reading your code. So you need to just go with that convention. So the self is just a naming convention. You can call it whatever you want, but you just have to remember that Python programmers are also reading your code. So just go by that convention. And the Python class also needs a way to refer to itself. So it's just a way to tell one instance from another. So the word keyword is just a way to describe itself. So we'll look at an example and you understand what I'm talking about, even though that self keyword looks very strange. So let's put it back and call it self. And this is where we initialize our attributes. Inside these two parentheses, we say comma, and with our dog class, we just need two attributes. That's what we need. You can pass in as many as you want, but we just want to go with a simple form. So the dog has an attribute called a breed, and then it also has a color. So let's stick with this for now. And then once I enter, I'm going to use the keyword self again. Self, once I start typing self, it pops up. Dot breed is equal to breed. Self dot color is equal to color. Yeah, with this, just a simple form. You can do some validations here, but just a simple form. We don't want to go into that yet. In other lessons, we'll look at all this, but the basic form is this. So whatever we assign to the class, once we call the class dog, whatever we assign to it, it's going to reassign it back to this breed. So that is the idea. So you are initializing. So the init keyword itself, it's very easy to comprehend. Init, so you are initializing. That's what it means. So if there are no other questions, I'll proceed with the functions of the dog. So we all know a dog can bark. So let's just create one function of that dog. So let's assume this our dog can only bark. It doesn't do any other thing apart from barking. So we say def bark, and then we pass in the self. It automatically gives you the self a keyword, so you don't have to get worried about that. And we want to print our dog is let me put it, our dog is barking. That's it. That's all we want to do. So our class has two attributes, breed and color, and then one function that this dog performs is to bark. That's it. So once we do this, let's create another. Let's create another file. We're just going to call it app.py. And you can see the level. You see the app.py is outside the example package, which is the green folder right here. It's outside it. So we want to call this class, this dog class, inside the app.py file. So you see, we are in a different folder, and our app.py. Yeah.
Your font size is very small. Is there a way you can zoom out a bit?
Okay.
Because on my screen, it doesn't, it can be, I can read it, but it's very, I feel like it's very tiny. But if that would be too much. of a hassle. Just continue.
Yeah, I'm going to switch to the VS Code for this same exercise. So I think that one should be a little bit bigger. So
okay.
And then to if you don't mind, can you please try like Control Plus and see? Because for most IDEs, this doesn't work.
I think I can only increase the font inside the .py, but it's not able to increase it outside from this side.
Yeah. Okay, no problem. Yeah.
So I'm now outside this package. So now how I can call these doc classes, I'm just going to use the keyword from demo1 dot example, and then dot the doc, which is this doc file, this one, and then I'm going to import the doc. So as we started, I explained from this website. You see, basically this is what they are doing. So it's just a folder structure, and you call you go inside the folder by folder, and at the end of the day, you hit the file, the last point, and then you say import the class. So if you look at this is our doc class, and this is the doc file, which is here, and then this is the package example, and then the top level folder, which is the demo. So now we can say D is equal to doc. So once we do that, you see, we get some intelligence telling us that we have some two attributes, which is the breed and then the color. Okay. Let me see if I can. Is it a little bit big, or I should increase it more? Let's see.
I think the base, like you said, the editor text is good.
Yeah.
It's just that the icons are small, but it's good. I think otherwise you run out of time. So
Yeah. So with the dog, we need to pass in two attributes, and the first one is the breed. So we can call it coders is the name of our coders. Okay, let me call it something. Shepherd. Let's call it Shepherd. And we pass in the color, and this dog is cyan. Let's assume that. And once we do that, let's remember our if underscore name is equal to this, just to run it with this green button. So now we can say D dot. We can print the color of this dog. Okay, so let me put it this way. The color of our dog is self dot D dot color. Then we can also print the breed of our dog is D dot breed. And then now we can also print.
Quick question. I noticed there's an F in your print. Why is that F? And then also, is the D a shorthand way for referencing dog? And how does Python know? Oh, it's at the top. D is cut. Got it. But the F,
so the
print
F is just
one, yeah, that one I don't
So
understand.
if I want to reference something, it's just a formatter. If I want to reference some variable inside the double quote, I can start with the F, because if I don't start with the F, you see it assumes that it's just it's part of the string.
Mm-hmm.
So I can do this. You see the color changes.
Got it.
Yeah, so now we can use the dog, which is the dog object. So here, this one is the dog instance of the dog, and we are calling it D. Just call it D. You can call it whatever you want. But now we want to now use the D object to access our back, the function that this dog performs, which is this one, back. So if I say back, so now you see, so these are the various ways we can access our attributes as well as the functions of that class. So if I do this, if I click on the green button, play button, you see, this is the output. The color of the dog is this. The breed of our dog is shepherd, and then it prints also the third one. The dog is barking. So now you can see clearly that this way of creating classes is reusable. So I can package my Python application, and what I can do here, let me create a README file, readme.md. So I'm creating a README file here. And what I can do is usage of dog class. And then all I need to do is say, I'm going to copy these tools, all this. And then I'm going to say d dot read, d dot color, and d dot back. So after I'm done packaging all this application, and I document my code this way. So if I document my code this way, so okay, so let me put the last thing here. Let me put this. How to install, and then I'll just do this pip install. Let's call it dog. Okay. So anybody who takes my code will just have to follow this instruction. We'll just copy this and paste it in the terminal, install it, and then copy this, paste it wherever you want to paste it, and then copy this one as well, and then run this and run that. So if, let's say William also comes in and want to make use of my dog class, and he will probably want to pass in different parameters. Maybe his dog is, let's say, hash puppy or something, and then he will pass in black. So now you can see clearly that the code is not static, it's very dynamic. So once it happens this way, anybody at all can pick your class, make use of it. So let's assuming that this class it calculates the area of a circle. So you want to create a class in this way so that anybody who wants to use your class to calculate something, they can pass in different parameters in there, and it does something for them in their own way, however they want it, however they want to customize it. So if you go to so many repo, this is what they do. They after writing their classes and everything, they document it, the Python packages with it. This is how they document it. Yeah. So any questions so far?
Yeah. So Theo, so the markdown, I see you have like a shell next to the tick tick tick. Is that what triggers that run cell? So if you go back to your markdown, the raw markdown file, yeah. So you see you have a shell online. Yeah. So the shell is what triggers that double arrow, right?
Yeah. So yeah, I can even change it to let me do this. I can even do tick 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 and then do Python and then paste in the Python code. So if I change it, you see now it's almost the same, but the color changes. You can see the keyword, just like the way we have the keyword green and things like that here. So basically, you get it that way. So once you do the tick tick,
so I'm talking about the double light green arrow. Is there anything special to what you have on line 2? When you went to shell, you see, when you went to Python, what you had on line 2 didn't show up. That double arrow. Yes, that double arrow. Yes.
Yeah, it's assuming this is a real package, I can click on it to install it.
Oh, okay.
Yeah. Okay. You see, it's telling me run in terminal.
Yeah. Okay.
Yeah, so if I click on it and it's a real package, it's going to install it right away.
Okay. Go.
Yeah, so basically this is how you document your class so that somebody else can make use of it. So we can move on. So I think I ran this and we got this results.
Theo, there's a hand raise. Ashley, you can come off mute.
Yes, hi Theo. I was wondering, what's the relevancy of learning like breeds and like the functions that we're doing right now from like your experience? I'm just curious because I'm very new to Python, so this like brings back like statistics and science. But what have you like? Kind of what's the kind of? I know it's kind of a broad question, but what is the significance or value learning this in your experience? I know we're kind of going maybe a little off topic, but kind of relevancy to learning this, the functions and the different attributes.
Okay, so I'm going to give you a new demo so that you can see the relevance of what we've done so far. Okay, so we want to create another class. This class, we're going to call it, let's say cylinder. Sorry, let me rename this. Cylinder. And let's go to Google before we start. So if you look at this object here, it's a cylinder. Okay, so and then the volume of this cylinder is, let's say, pi r square h. That is, if you want to calculate the volume of this object, it's pi r square h. And if you want to calculate, let's say, the surface area, this is the formula you need to use. And let's say the radius is 5 and then the height is 2. So once you do this, this is your result. So let's say you're in the lab and you want to calculate some of these things. You can write your own class that can compute the volume of the cylinder as well as the surface area. So we are going to translate this formula into a Python code, and then we translate the volume also, which is V is equal to pi r square h. So that is what we are going to do right now. So now we're going to create a class called class, and then we're going to call it cylinder colon. And then now, what are the attributes of this cylinder? You can clearly see that there are two attributes, which is the radius of this object as well as the height. So these are the two attributes. You can also see it here, radius and then the height. So those are the two information you need to be able to calculate the volume, even though there's another one here, pi. Pi is a constant, so you can easily get that defined or predefined. We'll look at that. So these are the two attributes. So let's go back. Now we say the def underscore init. Now the two attributes we are looking at is what? The height as well as the radius. So there are cases where you can initialize a value for the height and then the radius. Okay, but we are not going to look at it here. So assuming the user doesn't supply the radius and then the height, we can pick some default values. Let's say the radius is 1 and height is 1, whatever value you give it. But I'm not going to do it today so that you don't get confused. So now we have the self dot the height is equal to height. As always, you'll be doing it over and over. Radius is equal to radius. Now, the next thing we want to do is to calculate the volume. And we know it's what? Pi r square h. And pi, we know pi is like 3.14, some other numbers. So now, def volume. So we're going to return it's what? Pi 3.142. We're not going to take all the numbers. Times self dot height times self dot radius. The radius squared. This is how you pass in the radius squared. I don't think I even need the parentheses. It says it's what? Redundant, so I'm going to remove it. So this is the how to calculate the volume of a cylinder. So as you see, pi. Okay, so I can change the position so that you don't get confused. So you can do this so that you can easily. So on the formula on Google, you can see that it was pi times the radius squared times self times the height. So what this self is doing is that it's just referencing these values here. That is all we are doing. But if you don't use the self, let's omit that. You see the red wiggly signs around there. It tells you that you need to replace the height with self.height. You see, so the ID is intelligent enough to be able to tell you that you need it. You need the self.radius. So the last one we want to do is the surface area. So if you look at this surface area, is this formula right here, 2 pi RH plus 2 pi r squared. So let's go back and then define our surface underscore area we're not passing in any parameters, so we can say return. The first part is what?
2 pi.
2 pi RH. 2 times 3.14 self dot radius times self dot the height plus the other one is what?
I think it's 2 pi r squared or something.
2 times 1 4 times self.
Let me check for you. We used to know all these things off memory. Theo, there's a question in the chat. It's from Ashley. She's saying it seems like attributes can vary greatly, be descriptive or quantitative like a formula. Can you explain why we label everything self? Thank you, Theo.
So the self is a convention, as I stated before. It's so with Python under the hood, self is just a naming convention. We could have done this. Ashley, and then we pass in Ashley. Ashley, we could have done all this. Okay, so it's just a convention, and you can call it whatever you want, but you need to remember that other Python programmers are reading your code, as I said before. And the word self is a way to Python refers or describing itself. So that is the idea. So with this self or Ashley, you can use it to reference so many attributes of your class. So that is the idea. So most of the code you end up seeing this this self thing. It's a Python convention, so you just have to stick with it. Unless of course something changes in Python, yeah, you might end up using something else. But you can call it whatever you want, and it will work perfectly the same way. How to calculate surface area. Okay, so and there's a Python value for pi in okay, so let me do it here so that everybody can benefit. So there's a, let me see, from math import pi. So Python comes with things like pi, cosine, sine, all these square roots. So Python comes with all this. You don't have to create all these cosine, sine, square root, pi, and all those values for yourself. Python automatically comes with it. So instead of using this 3.14, we can just pass in pi here. And just pass in pi here, and it should work fine instead of trying to define it yourself. Probably you might end up using 2 decimal places, but we want to use the full length of pi. So basically, this is a real world scenario where, okay, let me change this one to pi. So this is how you can implement a class with the attributes, the functions, then the functions. So now let's go back to our app.py. So what I'm going to do is I'm going to call that cylinder. No, let me see, where is it? Yeah, I think cylinder. Yeah, it's cylinder. So I'm going to call that cylinder class. So I'm going to say from demo1.example.cylinder import cylinder. So now I can instantiate the cylinder class. So I'm going to call it C is equal to cylinder. And remember that we need to pass in some two values, which is the height and then the radius. So let's say our height is 2 and our radius is what, 5. So let me comment out this dog stuff. Okay. So I'm commenting out the dog stuff. So what I'm going to do here is I'm going to say print c dot height. Okay, let me put this height of cylinder as c dot height. We want to also print radius of cylinder as c dot radius. And also we want to calculate volume of cylinder is c dot volume. And the volume, we don't pass, it doesn't accept any argument. So it's going to be empty parentheses. So we don't pass in any value. Also, we want to check the surface area of cylinder is c dot surface area. That also is what, empty. We don't pass in anything. So basically, this is how you can, let me take out the dog stuff. We don't need it, assuming this is just our yeah, so basically that is it. So what this is going to print is going to print the height, which is 2, the radius, which is 5, and it's going to use the radius and then the height to calculate the volume, as well as use it to calculate the surface area. So if we run this, so you can see the height of the cylinder is this, the volume is this, and then the surface area is 75. So if we go back to that website on Google, and we want to calculate the volume, and then the radius is 5, the height is 2, you see, we get a 157 as this. And then the surface area also, radius is 5, height is 2. You see, we get 219.
I think there's something wrong with the formula or something.
There is 2 pi RH. So let's look at the formula. 2 pi R. 2 pi
I think there was a squared in the
square.
Second. Yeah, the square for the
it's radius squared, right?
Yes.
Radius squared. Okay, yeah. So I think we got it now. 2 pi r squared. 2 pi r squared. Okay, yeah. So if we run it again, yeah, now we got it 219.911. So actually, does it answer your question? How you can, so basically, if I want to document this code, what I need to do is to copy all this. So I can come back here and say how to use cylinder class. So I can just paste in. Let me clean up some stuff. Yeah, I can even leave it this way, but let me clean up this side. Yeah, so this is what you can share with, if you need to install something first before this thing, you can just do the same way as how to install cylinder class or something. And then you say tick, pip install cylinder. And maybe probably you have a version, you can put a version however you want it. So basically, anybody who takes your, let me see if I can do this. So anybody who takes your cylinder class, this is, just a second. Yeah, anybody who takes your cylinder class, this is what they can do with it. So they can vary the parameters, which is the height and then the radius. Is everybody okay so far? Okay, so if you how many minutes do we still have?
You're doing good on time. You have about 20 minutes, 21 minutes.
Oh, okay. So let me do another one, another special class. I have so many of them that I don't know. Yeah, we'll do all of them before we finish this lesson. So let's create another class. This time
But I think to answer Ashley's question, I'm thinking of learning from you and what you are doing. Ashley, I think, with Afia and William, we were writing a lot of lines of code to do specific things. But this feels like, going to the post office and choosing that envelope that already has the stamp, and then whatever you put in, you are able to sort of manipulate it or ship it at a certain cost. This feels like it will take time to definitely learn, but it feels like it's a smarter way to also consider in your Python toolbox. Does that help, Ashley? Or are you getting the same sense?
Yes, it's yeah, it's a different way, I feel like, to kind of write a formula, but it's much more plug and play. I feel like, well, and all coding is really more plug and play, but it's definitely pretty versatile.
Yeah, because I like the idea of your code being shareable immediately. you write the classes. Gentlemen, you are quiet all night. Any thoughts? Robert and William?
I agree with Ashley. It just pretty much based on, how you use it, and it makes sense.
Okay.
At least to me, it makes sense.
And William, yourself?
Yeah, it makes sense to me as well.
Okay.
There's another, like Ashley kind of said, it's kind of building everything up front, and then, that way you, or I think maybe you said it, that way you build everything up front, and then you can manipulate it to do whatever you want it to say.
Okay. Ashley has her hands raised again. Ashley?
Yeah, I guess the only thing that's kind of confusing for me is just like how many files or what we take from other files to that is required to use this type of formula and functions and class and attributes. So like I know in the top it's just understanding that like from demo01.example.cylinder, like that's really new for me, is like what we're drawing from. So really understanding the files that we need for all the information that it feeds into.
No, the demo is just, and Theo, correct me if I'm wrong, but I'm testing my muscle here too. I think the demo actually is the folder. So it could have been any name of, let's say you wanted a folder name, and you instead of demo, you wanted to call it example, then example 1 will be the first stuff, the first thing you reference. And then there's the package, he said. Now, Theo, I also had a question about the package. I'm not sure, the website that you showed us, the dot was with 2 words, but you have 3 words dotted, and you are calling the middle one the package, right?
Yeah, so depending on however you define, maybe this could be my package. For instance, the top level could be my package. Okay. And that one is going to be just one level. And all these files here will be under demo.
Okay.
And in that sense, I have to just remove this and make it demo1 dot the name of the file.
Okay.
So I
you
don't have to
extra tier involved than what we saw. So Ashley, so the folder, then the package in this case, because Theo preferred that, but then the cylinder will be the file that resides in the folder. Yeah. So then the import is the class that you have already defined.
Yeah, this name is referencing this name. Yeah, so this is what we are calling, and this is the name we are calling. The name of the class itself. At the end.
Oh, I was gonna ask, is that in the file within the demo folder? That's just.
Yes, this one.
Oh, okay, got it. And those are all just .py like files. Okay.
Yeah, these are all .py files. So this is very convenient way of making your code very modular, in the sense that imagine you are asked to create a class or a package for, let's say, different math objects, like let's say cylinder. Let's say you want to calculate for a square, a rectangle. All these are different objects, so you can create different PYs for each of the objects. And for each object, you define their specific attributes and methods, so that if something breaks, you know that, okay, I know square, the object square is breaking, so let me just go into square file and fix the issue over there. So you don't want to combine everything into one file. When stuff start breaking, you find it hard to detect where you have to go. So that's why it's good to put all the different objects in their own files.
Yeah, that makes sense. Ashley, does that help?
Yeah, that definitely helps. It's this is a good organization lesson, and I agree with you. It's very modular indeed.
Okay, so let's do the last one. So I'm going to create another file, which we are going to call temperature. Temperature. See, so now we have the temperature.py file. It's empty. Now let's go to Google and search formula for Celsius. Let's see. I hope I can find the formula. Okay, so this is the formula. Fahrenheit is this: C times 9 on 5 plus 32. And if you want to convert Fahrenheit to Celsius, Celsius is equal to Fahrenheit minus 32 times 5 on 9. So basically, we want to create our Python class that can convert between these two numbers. So let's start. So we're going to call the class temperature converter. So that's the name of our class. And what do we need? We need C, which is the Celsius, as well as the Fahrenheit, to be able to calculate the temperature. So what we can do here is we can say def Celsius to Fahrenheit. So what we need inside this function is Celsius, which I'm going to call C. Let me see, C. And we're going to return 9 on 5 times C plus 32. 9 on 5 times C plus 32. So that is our formula to calculate, to convert from Celsius to Fahrenheit. Now we want to do for Fahrenheit to Celsius, and that will need the Fahrenheit. Now we can return this F minus 32, 5 on 9, 5 on 9 times F minus 32. So how to convert from Celsius C to F? How to convert from F to C? And one thing also that I want to add to is there are cases where we can just call, they call them static methods. Okay, static methods. So what this does is that all you need to do is to call the name of the class dot the name of the function. So what we'll do here is to decorate the function with the built-in method, which they call static method. Static method. So now we can remove the self, which is redundant. So basically, that is our temperature converter class, which is very straightforward. So if you are building a function to calculate these two stuff, yeah, you can put them in just one single file and then call it wherever you want. But it's always good to put it one place so that you can refer to it or call it as many times as you want. So now we are done.
Quick question, the static method, I got up to do something, sorry, so got distracted, but what's the static method about?
Okay, so it's very simple. You see, there are cases where we have to instantiate the class to get objects, and then we use the object to get the attributes of that class or the methods or functions of that class. We don't want to do that. We don't want to go to that long route. So I'll show you what it means by what we've just done, and you understand it. If you come here, you see we're instantiating like this. We call the class name, and then we assign it to some object. And then we use the object to access the methods and then the attributes. That is what we are used to so far. So this time I don't want to do that. It's just too much, it's too long. So I want to say from demo1.example.temperature. You see temperature is popping up as the file. We want to import temperature converter. That's what we want to do. Now, because I don't want to instantiate the class, what I want to do now here is print. I want to just say temperature. Okay, let me do print. I want to just do temperature converter dot Fahrenheit to Celsius. You see, before then, if I have to instantiate it and give it to an object, and then now use the object to access the methods. But this time I don't want to do that. I just want to call the class, the name of the class, dot the name of the function or the name of the method. So I can call it name of the class dot name of function. That is what we are doing. So now, to be able to convert from Fahrenheit to Celsius, we need to pass in Fahrenheit to Celsius. We need to pass in the Fahrenheit. So let's say the Fahrenheit at this point is 86. And then we can also do this temperature dot Celsius to Fahrenheit. So let's say the temperature, the Celsius is 30 degrees Celsius, and then we have 86 Fahrenheit. We want to convert it to Celsius. So you see, this way is also very straightforward. We don't have to instantiate. If we wanted to go the instantiate route, this is what we would have done. We would have said maybe temp is equal to temperature converter, and then we'll do this. We don't want to go this route.
So in this case, the function is acting as the object, or no?
Yeah, because we decorated the method with this thing, this at static method.
Oh, okay.
This is what is changing the dynamics.
Okay.
And it's built in. We did not define it ourselves. It's a built-in something you can use.
Okay.
Python already gave it to us, so we can just make use of it. Okay, so we can also do this. T is equal to this entire thing, and then say print T. We can as well do this. We can assign it to some variable, and then now print the variable. Okay, so we can say temp, let me see, F2 T is and then we can also print this and say C to F is yeah, so we can do this. We can assign this whole thing to a variable and call it here, or you can decide to just ignore that and just pass in everything. So once we hit the green play button, you see this small little thing here just to print 50 dashes, just to separate it. Yeah, so you can see from Fahrenheit to Celsius is 30, and from Celsius to Fahrenheit is 80. So whatever, if we pass in 90, and then Celsius is 33, let's see what we get. You see the values have changed. So again, we can document this code. And say usage where is it? So this is how we can document this code. And anybody who has access to our code, they know this is how they need to use our code, so that they're not going to be running around and be instantiating the class. They know that, okay, it's a static method, and just call it this way, and it should work. Yeah,
how
so
does it know it's a static method? Is it because it's orange looking?
If you
I know the
orange,
static method. You said they will know that is a static method, and so my question was, how do they know from this usage code that this is a static method?
Yeah, because they know I'm not instantiating. I'm just calling the name of the class dot name of the function. So if you're a Python person, once you see the first one dot something, it means that clearly it's a static method.
Okay. Okay.
Because with this, you can see that most of the time I have to instantiate this way first. And then the next thing I have to do is now use the object to access the method. But this case, I'm calling the class directly and then calling the method on it.
Very good. Theo, the syntax that you typed in this lecture, if you can extract them and send me, I can put it in the Teams folder so learners have.
Yeah, I think each time I'm done, I'll just give out this folder.
Okay.
So that everybody else can practice with it.
Okay. Thank you.
Yeah.
Well, we are at time. So any last minute thoughts?
Yeah, I think how many minutes?
We are at time, so you have 1 minute. Okay, you can have 3 more minutes to 7:20, but
okay, 3 more minutes. So maybe possibly next. Okay, so this is the VS Code. Okay, so if I would wanted to do the same thing in VS Code, I would have created. This is a folder. I would have done this. Let's call it demo. And inside the demo, we want to create a file. And because I want it to be like, let's call it area.py. Yeah, I would have done, let's say, class. Let's say it's a circle. Circle, what do we need for a circle? We need a radius, right? Radius. And I'll say dot radius is equal to radius. And then I can calculate the area of this circle, area of this circle, and say return area of a circle is what? Pi 3.142 times pi r square, right?
Mm-hmm.
So basically, this is just a simple class. And all I need to do now is to say circle is equal to circle. And then I have to pass in the radius, which is, let's say, is 5. And then I can print. Area of circle is C dot area. Yeah, so basically I can do this.
Mm-hmm.
Using the VS Code. So let's run. You see, the results is showing up. Let me clear my terminal and then run it again. You see, the area of the circle is 78.55. So we could have done the same thing that we did using the VS Code. Assuming I want to call, this is just in one class. Assuming I want to make this into a class, I could have done this __ init ___.py, and then clean up this, and just leave the class alone. I'm just going to leave the class alone. I don't want to do anything inside that area.py. So now I can create a new file, which I'm going to call app.py.
Theo, we have time, so we may want to continue.
Yeah, just let me just do the last thing, 1 minute. So now the class is left alone. So all I need to do is say from demo dot area, I want to import circle, and then I can say main. Okay, I already copied it. Okay, so once I import the circle from this folder, demo.area, which is the name of this file, this app.py is outside the demo folder. You see, it's outside it, and I can just import it and then instantiate that circle class and pass in the radius parameter, and then now do this inline printing. So if we run this app.py, we should get the same thing.
Very cool. You have a good comment here. Ashley is definitely interested to see how she can use this modular method for other real-world conversions or applications. I like this method, and it's very organized to fix errors. It may be helpful to define attributes, methods, and functions, because it can be kind of abstract for beginner coders. Thank you, Theo, and thank you, Afia. So you already have your feedback for tonight. Any questions? I know we've already run over time, so it's okay if you want to join your question, but 30 seconds for a question, and then other than that, have a lovely evening. And remember that we will have a guest lecture on Saturday because Theo will be absent, committed to some other personal appointments. But we'll have Theo back next week, Tuesday, and the Saturday after that.
Yeah.
I see Robert is writing, so I will give him a minute. Okay, thank you. Robert says thank you. And William also says thank you for today's class, and have a great day, everyone. All right, have a good evening, everyone. I suppose William is somewhere where it's day. All right, bye-bye.
Yeah.
Thank you.
Okay, William is just tired. Okay, bye. Hang
Bye.
in there and see you. Theo, thank you so much. Thank you. I thought it was a great lesson.
Yeah, it just needs
and you need practice. To teach me your home setup. I really like the podcast looking. Are you making podcasts? And I like the angle of your camera. So you need to help me with that.
Oh, yeah.
Yeah, but I'll call you and we'll talk later. Right now we are recording, so I will drop off.
Okay. All right. Sure.
Bye.
Yeah, bye.